Hi. In this video, I'm going to talk about sections 9.2 and 9.3. In this section 9.2, the mouth, pharynx, and esophagus. And the mouth is the oral cavity, both chemical and mechanical. Digestion start there. Chemical because we've got some enzymes in there in our saliva that start breaking down starch, and mechanical because of the movement of our tongue and our teeth to break down food physically. Um, let's see, there's some anatomical parts that are kind of interesting. If you run your tongue over the roof of your mouth, the front or the anterior part is hard, and so we call that the hard palate. And so there's actually bone underneath the gums up there, the mucous membranes up there. But then you carry your tongue more towards the back, and all of a sudden you can feel like a softer area, and that's called the soft palate. And the bones beneath there, they're called the palatine bones, and that's where they end, about there. And so we've got all this soft tissue that leads to the throat, the pharynx. And most of us, I don't know, if when you're a little kid, we find the uvula very fascinating. But it's just a piece of tissue that hangs down, and it probably serves some purpose in helping you prevent liquids from going up above the soft palate into the nasal cavity. So when you swallow, that kind of shuts off, and most of the time, food or liquid does not get up there. Again, that most of us have had looked at our tonsils in the mirror, and tonsils are actually lymphoid tissue. They're glands. They're like kind of modified glandular tissue, and what they do is they trap like dust and bacteria and viruses that are coming in through the air as we breathe. And they interface with our immune system and our cardiovascular system, and kind of show our immune system that, hey, here's some bacteria I found, here's some viruses I found. And it stimulates your immune system to make antibodies against different microbes. Now, we spend most of our childhood with pretty big tonsils, but as we get older, they start deteriorating. So somebody may, even sometimes by your 30s or so, you can look in the mirror in your throat and you don't even really see tonsils anymore, even if you've never gotten them out. And that's because the immune function of those has pretty much, they've done their job. You know, they've exposed you to a lot of things when you were younger, and you don't really need that tissue anymore because you've been exposed to so many different pathogens. Let's see. I didn't talk much about teeth just because we don't have time, but I talked a little bit about the salivary glands, and we looked at them in the previous video. They talk a little bit about mumps here when you get enlargement of the salivary glands. I am old enough to have gotten mumps when I was a little kid. I remember being sick for missing like 2 weeks of school, and that was before we got the MMR shots. So most of you probably have never experienced mumps because of that. But that's an enlargement of the salivary glands, and one of the things, you know, we know they make saliva. And if you ever tried to do that thing, like when people swallow cinnamon, it dries up your mouth and you can not swallow it. It's really hard. And it really highlights the importance of saliva in being able to manipulate food in our mouth and to swallow. So the moistening of our food with saliva is really important. And then another thing that's important about saliva, it has an enzyme in it called amylase, and amylase starts the digestion of starch. Talking about mechanical digestion there. Okay. This term, a bolus, that's when you start chewing and you pull the food kind of together to give it in a unit that you can swallow, and then that unit of food can go down your esophagus. And so once you've kind of chewed and pushed this chunk of food together, we call that a bolus. So again, the saliva is really important for that, and the tongue is really important in trying to get that food into a kind of a ball that you can swallow. I mentioned that the pharynx is known as the throat, and it's a passage for food and air. Swallowing's kind of interesting. You know, we've all had that experience where you go to swallow and then you can't get the reflex started for some reason. It's really highly coordinated, and the consequences of inappropriate swallowing are pretty severe. It means you could actually put food or water into your lungs, and that can be deadly or, dangerous to deadly. And so here's kind of a picture showing you the process of swallowing, of how the tongue has to be involved. I mean, you can't swallow with your tongue sticking out. It just isn't possible. It doesn't trigger the reflex to do that. But here's the food coming together, the bolus, and pushing against the hard palate and the soft palate. And see here how that uvula is hanging down on the end of the soft palate, and it's blocking off this the throat that goes to the nasal cavity, the pharynx region that goes up there. So the food should head down this way, and as you swallow, the trachea is going to move up, and we'll talk about that when we talk about respiratory next week. And it actually touches against this kind of cartilage flap called the epiglottis. And what it happens is you can see this bolus coming down, pushing the epiglottis down, and the food, instead of going into the trachea, stays in the esophagus. So the trachea goes to the lungs, the esophagus goes to the stomach. So this swallowing mechanism is designed to prevent the food from going into the trachea, but to appropriately go down into the esophagus. And then once it gets down there, we mentioned peristaltic contractions in the last video, that we get these rhythmic contractions of the esophagus that are going to push that bolus down into the stomach. There's a term here that says the lower gastroesophageal sphincter. A sphincter is a round muscle that closes a tube. So we have sphincters at the top of our stomach, at the bottom of our stomach, closing the tubes to enter and leave the stomach. We've got sphincters in the anus is a sphincter, that closes off our digestive tract, so we defecate in a controlled manner. Something that can happen if you have a problem with a particular sphincter is heartburn. And so if the sphincter, this lower gastroesophageal sphincter, doesn't work very well, food from the stomach can go backwards into the esophagus. And in the first video, I mentioned that the acid in the stomach is neutralized before it's released into the intestines. But if it goes from the stomach to the esophagus, it's still highly acidic. And so this sphincter is really important. If you overeat, this sphincter might not close well. There's different medical conditions that people have a problem closing that sphincter, and they get heartburn. I'm going to go to section 9.3 because there's a little story here, summary of heartburn, that they're calling GERD, Gastroesophageal Reflux Disease, also known as heartburn. So that's the idea that the stomach acid is going through that sphincter muscle and up into the esophagus. Women that are pregnant get GERD because the baby's kind of pushing on the stomach and pushing the stomach acid up into the esophagus. So, and heartburn can be pretty dangerous. It's very uncomfortable. It's not a pleasant thing, but there's also other complications, including cancer of the esophagus, which can happen with frequent GERD. So this is something to be really taken seriously. And there's ways to kind of reduce problems associated with that if you read that article. We're going to just talk a little bit more about the stomach, and let's see, I think like I said in the first video, the common misconception is that the stomach is doing most of the digestion. That is false. Most of the digestion of our food happens in the small intestine. The stomach is mixing the bolus with the stomach acid, and once it's mixed with that, now we call it chyme, C-H-Y-M-E. And you can see that the wall of the stomach's really muscular, so it's going to mix up that food, make it a lot more watery. And there's some digestive enzymes in the stomach, particularly some enzymes that are activated in acidic conditions that help digest protein. But the main thing the stomach is doing, it stores food. So you can't digest everything all at once. It makes sense to digest a little bit at a time. And so the stomach's going to store the food and then release units of it into the small intestine over time for digestion. These are kind of cool pictures showing you the inside surface of the stomach. And here's showing you some peristaltic contractions of how the food is pushed down and out of the stomach. The small intestine is named for its small diameter, not its small length. It's actually longer than the large intestine, but it's narrower. So it's called the small intestine. It's about 18 feet in length. So 3 or 4 times, well, maybe not quite 4, but definitely 3 times longer than most of us. And it's got some important, so it says it's the main digestive enzyme. No. There we go. Yeah, it's the main organ involved in digestion. The other thing that happens in the small intestine is it's really important in absorption of nutrients. So once you've digested food into smaller parts, like polysaccharides into monosaccharides, they're digested, they're absorbed into the bloodstream through the walls of the small intestine. So 2 really important functions of the small intestine, which are really 2 of the premium functions of the digestive system, is digestion and absorption of nutrients. There's a list of some enzymes here. Lipase is an enzyme that is important in the digestion of lipids. Amylase, we already mentioned, is important in the digestion of starch. And there's different kinds of protease enzymes that are involved in the digestion of proteins. Here we talk about nutrients and absorption of in the small intestine. And one of the really important concepts in biology is that a lot of times you want to increase surface area, and you do that by folding. So if you look at the inside of the small intestine, it's got all these folds right here, and they're called villi. And if you take a villus, you'll see that there's folds on top of the folds, and they're called microvilli. So the surface area of the inside of the small intestine is huge compared to if this was just a flat layer. Now, if I do all these folding, I can get a lot more surface area. And that's highlighted, that's really important because of that absorption function. If you're absorbing things from inside the small intestines through the walls into the bloodstream, it's much more efficient if you have a lot of surface area. So, and that surface area is created by villi and microvilli. And I think that's a good place to stop.